My name's Luke. I'm from the Bureau. I'm based in Melbourne. I'm actually part of a program called the Agriculture Program. It's actually a fairly new program, but my role is designed to engage with agriculture around the country and understand their needs and how we can improve our services to agriculture. Tonight, we're going to talk a bit about climate trends in the arid lands region, and I'll just start sharing my presentation. I'll give a copy of the presentation to Paul, so you'll be able to get the links and all the things that I present tonight, so don't worry too much about taking notes or anything like that. I'll just wait a sec to make sure it loads for everyone, but just sing out, Paul, if anyone's having any issues there. I assume that's going okay.
Yep, that's all good at the moment.
Alrighty, yeah. So I'll just give you a quick intro. Tonight, I thought I'd just go over some national observations and a couple of key concepts to keep in mind when we're talking about climate and climate trends. I'll tell you a little bit about a project that we ran last year called Climate Guides, which kind of has led to the discussion tonight, because what we did in that project was we created what we call a climate guide for the SA arid lands region. And I'll go through the findings that we found when we had a look at the data for the region. And then I'll just finish on a little bit about future projections and where you can find some more info, and we should have plenty of time for questions. Look, generally, I don't mind if people ask questions in the middle, but I think it's probably better if we leave them to the end, because it just helps us get through the slides, and I can always go back to slides when we have a chat at the end. So let's just start with having a look at what we're seeing nationally. And this is an example of temperature records, and something to keep in mind here is that this is when we look at national trends, we actually pull all of the data from across the nation. So this isn't one particular weather station, this is all of them combined. And what it really shows is that since about the 70s, 60s or 70s, we've continued to observe a warming trend. And if you look at the scale on the left-hand side, it's zeroed at what we call climatology, or the average, which is based on 100 years of record, and then it shows a departure from that. But the scale is only in half to 1 degree. So it doesn't, even though the graph looks like there's a really large incline there, it's worth keeping in mind that we're talking about half to a degree, 1.5 degrees. And that's probably something that is communicated most often in the media when they talk about Australia's had a 1 degree increase in average temperature in the last 100 years. And that's really what this chart shows. I guess the key concept here is that when we move the average, it actually changes the whole profile of the different range of temperatures that we can get. So this is the concept of what we call extremes. I'll just walk you through what's on the screen. The orangey yellow curve is what we would consider to be the previous climate. And you can see that it starts low down in the cold end, and then it peaks at the average. That's where the dashed line is in the middle. That's what we would consider to be the average. And then it drops down the other side into a hot area. When you move the average, even by half to 1 degree, it actually moves the whole curve. And there's a couple of things that happen. If you look at the cold end on the left, it actually means that the cooler temperatures that we used to get, or the really cold temperatures that we used to get, don't happen as often as they used to. But probably more importantly is at the other end of the scale, which is the hot end, and that is warm temperatures that used to happen reasonably or less often are now happening more often, and then temperatures that we never used to get are starting to occur. And so that's the concept of extremes, and it's just important to understand even though we talk about only half to a degree of average temperature change, it actually can quite significantly change what happens at either end of the scale or of the range of temperatures that we can encounter. And just showing some data again, and this is all, again, national data, but there's just some examples here where we're starting to see that in different periods. So on the left, there's a couple of curves there that show a period 1951 to 1980, 1981 to 2010, and an overlapping period of 2001 to 2015, but really just starting to show how that distribution is shifting. And on the right, this is a plot of the number of heat waves and how many of those we have in any one year, or the number of what we call extreme days. And that's just showing that how they're increasing as well. And again, just worth mentioning that this is data from the whole of Australia. It's not representative of any one particular weather station. So that was a bit about temperature. And so it's also worth looking at what's been happening with rainfall. So this is a map of how rainfall has been in the last 20 years, and it's rainfall specifically focused on April to October, which is pretty much the southern growing season. On the left is the legend. Basically, what it shows is that anywhere that's white is considered to be average, and that's average compared to all records back to 1900. Anywhere that would be blue would be considered above average in that 20-year period, and anywhere that's yellow to red are considered to be below average. And the red areas are actually what we consider to be the lowest on record. So lowest on record in this context means the lowest amount of rainfall in a 20-year period for any 20-year period in the last 120 years. But the other thing to note here is, again, it's not homogeneous across the whole country. It's really quite variable. There's some parts that have been impacted more than others. And so, again, it's not the same pattern at every particular location. Looking at summer rainfall, October to April, you can see it's quite a different pattern, and certainly from the centre and the west of the country, with the exception of the southwest, largely has had the last 20 years has been the highest on record for any 20-year period going back to 1900 for a large part of the country, but certainly not Tassie and I guess southern Victoria, and a bit patchy through the eastern states. So I'll talk quickly about Climate Guides, which is a project that we ran last year. It was actually a federally funded drought initiative. The idea behind the Climate Guides was really, like what we're talking about tonight, was to help people in their region understand more about the climate and how it may have changed over the last 30 to 60 years in their region. So a climate guide is a snapshot of a region's climate from 1959 to 2018. That might seem like an odd period, but the reason that we chose that is because we generally try to stick to a 30-year period. 30 years is a good sampling time to analyse climate records. Any shorter than that, and it makes it a bit difficult to talk about trends. And we wanted to compare two 30-year periods, so that's what we're going to go through tonight. The guides themselves had a range of topics relevant to agriculture, and they're based on NRM regions. So there's 56 NRM regions around the country, and each guide is a 4-page guide. There's a link at the bottom of this page, which you'll be able to get when you get a copy of the slides. But the way we went about producing these guides is we actually did 50 workshops around the country. This is just a map to show everywhere we did a workshop. We did a workshop in Port Augusta representing this region, and then we put together a 4-page guide for each region, and they're all available online. So tonight, really, what I guess the real guts of the content is to take you through what's actually in the guide. So you'll be able to get a copy of the guide really easily, but I'll walk you through tonight what's in that guide. In fact, I've got a little bit more info than what's actually in the PDF, and plenty of time for questions at the end. So one of the things that's in the guide is annual rainfall. And these charts here, I've just got a range of different locations where there's weather stations. And I guess you probably appreciate that there's not a weather station in every town. And these are also bureau weather stations. We're, in some cases, sometimes we're a little bit limited. And you can see that on some of the charts here. So we've got Arid there. You can see that Oodnadatta, actually, its record only goes back to late 1930s. Woomera is from about the 1950s. And I've just thrown in Tibooburra. I know that that's not in your region, but it's just a little bit further east. And it's also worth just comparing what's happening there, just to get a bit of a sense around us. But essentially, when we looked at this data and compared the last 30 years, and that's 1989 to 2018, when we were doing the project, it was during 2019, so we didn't have a complete year of record, so we didn't include that in the analysis. But when we compared that 30-year period to the 30-year period 1959 to 1988, the 30 years before, what we found out was that actually the average rainfall, the average annual rainfall, and that's not to say that's exactly how much falls every year, because you can tell by these charts that, you have some wet years and you have some dry years, and certainly the 70s, late 70s, 60s and 70s were a wet period for the region. But on average, that average rainfall hasn't changed, and it's actually remained fairly stable at around 180 millimetres on average for the whole region. And of course, that's a generalisation across the whole region, and it's different for different locations. But on average, that hasn't actually changed. But a couple of things, I guess, around that have changed. So we also did an analysis of how many wet years have occurred in a 30-year period versus dry years. And we classified wet years as the top 30% of rainfall records and dry years as the bottom 30%, and everything in between is considered average. And in the period 1959 to 1988, there were 13 wet years, 11 average years and 6 dry years. But in the most recent 30-year period, there are a couple of less wet years. So there was 11 wet years, there was 10 average years, but where the average and wet years dropped, that increased into dry years. So there was an increase in dry years. And that's something that we've seen quite consistently across the country through a number of these regions. One other thing to consider, obviously, when we talk about rainfall that falls throughout the year, is even though the rainfall the average amount of rainfall that is received in any given year has remained stable, we also compared how much on average is falling in each month. So you can see here that these charts show Maari again, Oodnadatta, Woomera and Tibooburra. And the blue bars actually represent the 1959 to 1988 period, and the orange bars represent the 1989 to 2018 period. So anywhere that, and at the bottom I should say, represents the month. So anywhere that a blue bar is higher than a orange bar means that in the previous 30-year period from 1959 to 88, that the average rainfall in that month was a bit higher, and anywhere that the orange bar is higher than the blue bar is the reverse. So there's a couple of interesting things to have a look at. Let's just start with Maari. You can see that now. Also, just note the scale here. So we're talking about a difference of 5 to 7 millimetres, but it would appear that in the last 30 years that summer rainfall has dropped off a little bit. And you certainly had a bit more rainfall in the previous 30-year period, but it looks like March it has increased a little bit, but then again there's seemingly a small drop off through that autumn period. Look, again, these are fairly we're talking about not a lot of difference there, but it's just the sort of thing to keep an eye on, and you'll know better than I if that's impacting your enterprise. But you have a look again at Oodnadatta has a fairly similar pattern in January in terms of the drop, probably more of a drop. But then a little bit more in February and a little bit more in March, where that's offsetting perhaps what's going on there in January. So it's just changing, but again, just like Murray, a little bit of a drop in early autumn there. So just changing the timing a little bit of some of that rainfall later in the year as well, a little bit falling a bit early in November and December. That's also potentially related to what's happening there in January. Woomera has a bit of a later pattern through that as well. So you can just sort of go through and check out the different locations that are probably most meaningful to you. Woomera is an interesting example there because it looks like sort of late winter and through spring there's been some rainfall decreases, just a general pattern to observe there. So these are quite handy for understanding where there might have been changes to timing of rainfall on the monthly cycle, as opposed to just examining if the average rainfall over a year has changed. The other thing that's worth considering is rainfall reliability. And rainfall reliability isn't about the amount that you receive each year or each season, as I'm showing here. It's about how often or how consistent that falls. So in an area that is very reliable rainfall, the map would be coloured blue, and very reliable rainfall would mean that your average rainfall would only fluctuate by 10 or 20%. So if your average rainfall in that season was 100 mil, one year you'd get 100, the next year you'd get 110, the next year you might get 90, and that's around about the fluctuation that you'd expect for something very reliable. For something that's unreliable, that's the darker red areas. And I'm probably not showing you anything you don't know here, but it's just worth having a look at for interest. And so, if we think about it, probably summer is just judging by this map, summer tends to be more reliable. Not that it's at all considered to be reliable, but it certainly seems to be more reliable than autumn or winter, and a little bit off spring. And I should mention, this is the last 30 years. But there have been some changes to what's been happening to this rainfall reliability, and I'll just take you through that. I've actually got a map of the whole of Australia, and on the left, you can see rainfall reliability for the period in sun. So this is just for summer. So for 1959 to 1988. And you can see that the centre of Australia is really quite dark red. So that's unreliable rainfall. But that's actually improved a little bit. So the rainfall in the last 30 years has become slightly more reliable in summer than it used to be. But again, just need to consider that that's not saying that you're getting more rainfall. It just means that it's falling more consistently from year to year. There's also been a change in autumn, and again on the left, 1959 to 1988, but this time it's been a negative change. And so it's gone from being, not particularly reliable, but it's certainly gone to be less reliable or unreliable than it was previously for that period. And you can see that through that really dark red change across most of the centre again. Some other things have changed when we start talking about the combination of temperature and rainfall, and one of those things is frost. So these charts are charts of what we call frost potential. So frost potential doesn't actually mean that a frost occurred, but when we use our weather station records, we have when we record 0 degrees at the weather station, that's normally what we call screen height. So that's the height of the device that's behind the screen that records temperature. That's normally a couple of metres off the ground. And screen height at 0 degrees normally represents -2 on the ground. So what we've done here is we've taken all of the 0 degree screen height days, and we've just plotted them up for how many of those there were per week. And so again, the blue bars represent 1959 to 1988, and the orange bars represent 1989 to 2018. So anywhere that the blue bar is higher than the orange bar shows that that period, the earlier period, had more frost potential than it did in the later period, and anywhere that the orange bar is higher than the blue, is just showing that the most recent period has had more frosts than the previous period. But really what we're seeing here, if we just take Marie as an example, through May, June and July, there's been a real retraction of the potential for frost at that location, and that's similar at Tibooburra, and there's a little bit of that going on as well, probably through June and July at Woomera. There's not a huge difference at Oodnadatta. One of the biggest things that we have seen though is a change in temperature. At the start of the presentation, I mentioned that change in average temperature. But when we talk about, if we were to talk about a change of 0.5 degree to a degree, I guess it generally makes it fairly difficult to try and work out what that really means in reality and what that might mean for managing a crop or for managing livestock. So what we've done here is we've actually chosen a threshold. So in this case, it's 38 degrees. And we've plotted up each location and how many times the temperature reached 38 degrees in any given year. And then some of them, and I apologise, not all of the charts have them, but some of them have a running trend line, which is the average over the last 5 years. And you can see there with Marie that since about the 80s, there's been a trend upwards for the number of days per year that Marie's getting temperatures above 38 degrees. Oodnadatta is looking a little bit more stable, and there's quite a few records back in the 50s and 60s that are equal to today. So that there's no really clear trend there. Probably if we ran a trend line over Woomera, there'd be a slight trend there, and you can see a little bit of a trend starting to appear in Tibooburra, but you'd need to have quite a few more years record to make a statement about that. And you can also see that in some of the weather station data here, there's gaps, and that's where we might have had an issue with the weather station and not been recording for a period of time. So that would certainly be the case with Tibooburra and Oodnadatta. It doesn't mean that there weren't any days over 38 degrees. That'd probably be quite rare. Just comparing how many days have happened in the past. So again, this is comparing that period 1959 to 1988 to 1989 to 2018, and how many days on average occurred per year in those two periods. So just looking at Oodnadatta in the middle there, in 1959 to 88, it experienced on average 54 days a year above 38 degrees, or at least 38 degrees, and in the last 30 years the average was 62 days a year. So that's an increase of 8 days a year. Marie's had a much bigger increase there, going from 41 to 54 average days per year. Woomera 22 to 31. And I just added a few other locations in other surrounding regions just to show that the pattern is still continuing, not just in this region. And it's something that we've seen is also occurring across into Vic and New South Wales as well. So that pattern actually extends right across. So we'll finish just talking really quickly about future projections, and then we're going to have plenty of time for questions. The observations that I showed you this evening are consistent with future projections. So the future projections say that there's expected to be a further increase in temperatures, and that will continue to exacerbate that extremely hot weather and the number of hot days, like I just showed you, and fewer extremely cool days. And that's really what I've just shown you in the data tonight. So that's consistent with the future projections. And when I say future projections, I'm talking out to 2030. So still another 10 years from now, that's what's expected to continue. We expect the decrease in cool season or winter rainfall in the south to continue, with more dry years in between. So again, that's similar to what I described earlier, when in any 30-year period, there was an increasing number, in that second 30-year period, there was an increasing number of dry years compared to the wet and average years. So we expect that to continue. Summer rainfall changes are uncertain. And for I guess the key point with rainfall is that for the near future, natural variability will dominate projected changes in rainfall. So what that means is that we're expecting to still see those swings from one year to the next, where you might have a year where you get your average rainfall and then you might have one or two that you don't. And so we're expecting those big swings to continue to occur before we can actually make any real predictions about exactly which way rainfall might be heading. Rainfall is, as you would know, it's very highly spatially and temporally variable, and it's very difficult to forecast even 7 days out, let alone decades in the future. So we're less certain about what's going to happen with rainfall as we are with temperature. There's a couple of other sources of information I've used in the presentation at the start and the end tonight, and there's two key reports. One is called the State of the Climate. That's a report that the Bureau and the CSIRO author every 2 years. So there'll be a new State of the Climate report come out at the end of 2020. Basically, that report takes a lot of the images that I showed you tonight and explains in more detail what's happening around Australia, and includes projection information. There's also a website if you'd like to get even further detail on future projections. It's called Climate Change in Australia, and that's also a joint collaboration between the Bureau and CSIRO, and there's a couple of links down the bottom. And that is the end of the presentation.